Hey everybody, Adam Savage here in my cave, and if this angle seems lower and like it favors the workbench, it's on purpose, because this one-day build is all about this beautiful workbench. Now, this workbench was something I received during COVID, during the lockdown last year in the fall. Workbench designer and inventor and master maker Andrew Klein reached out to me based on me saying in one of the tested videos that I needed to upgrade my workbench, and said, hey, he said to me, I build workbenches and I would like to build you one. And lo, reader, he did, with its steel base, monolithic double slabs of unbroken, unlaminated wood as the main bench body, plus bench dogs everywhere. This is a lifetime bench. I'm gonna have this bench for the rest of my life, and I'm super grateful. And as I have been using it, there are a couple of things that I would like to change. Right now, the thing that I am going to be mucking with is these vices. Now, Andrew designed and invented and sells these incredible geared vices. There's a big wide one that's the width of the workbench, and then there's this one. And just to give you an idea of how lovely these things are, it's all, it looks like laser or water cut gears. It also has 2 speeds, so that's a fine speed for better control, and then faster speed. And as I have been using these, I have learned that I want a handle. I want to get a handle on the situation. Specifically here, this handle, as I'm doing it, I'm finding like that takes a lot of time, and I want to be a little more efficient about it. I want a handle here. I want a handle, but nobody wants a handle sticking out. In fact, actually, when you have a mill, dinging yourself on one of these or on the knee handle, this handle on the knee of a standard milling machine is literally like one of the things that every machine operator has like some mark in their thigh from banging into one of these, right? So if I'm going to make a handle, if I'm going to add some kind of handle for this vise, I'm going to need it to be collapsible. Oh, yes, it turns out they make folding collapsible handles. That is what I'm about to do. I have got a new piece of steel for the main body of this handle, and a collapsing handle attachment that will go to it. There's going to be a little bit of machining, a bunch of dismantling, remantling, and then hopefully the final holy testing it out. And we'll have a unique mod to my Andrew Klein vise. Andrew, if you want to take this mod and run with it, you go right ahead. Let's see if it works first, shall we? So right off the bat, there's a couple of issues with, so first of all, here are the folding handles that I have found. They satisfy several things that I wanted. I wanted them to spin. So I wanted this part to actually spin, which you have to specify. They don't all do that. Second of all, it collapses, which means it folds like this. So if the vise handle is sticking up like this, this can have its natural state like that. And then when I need to use it, I do this and then do the like that, right? And it collapses up pretty nicely. Yeah, and it'll have a pretty low profile there. However, if I just tapped this into this pipe here, this pipe spins here in the hole. That doesn't work. I need this not to be spinning this way as I'm trying to do it. Yes, exactly. I need a slot in the long piece of steel here and a corresponding pin in the handle to accommodate that slot. And that is another aspect of this. So I picked up a couple of pieces of steel that are the same outer diameter. However, they've got a thick wall that'll allow me to add a slot down most of the way of this pipe. Yeah. So these are the main components. I've got a thicker wall steel pipe, a collapsing handle, the original ends. So the order of operations will go, I'm going to choose a set screw that will go in here. Then I'm going to mill a slot, not all the way down. I'll explain that later. Then I'm going to mill a flat, tap and thread this for this handle, open up the ends to be able to receive these ends, and yeah. Got my 2 pipes. I'm going to shorten them until they're just about this length. Andrew has milled out the end of these to make them an application tool for the little retaining ring inside where the lead screws in this vise attached to their gears. I'm not sure I'm going to replicate that because I have it here, but size and then yeah. Let's see. I'm gonna get these onto the lathe. I'm going to mill them down and slice them, and then I'm gonna get them ready for the slotting. So I guess I can just jump onto the lathe. This is the tube I'm gonna put into my lathe, but I don't want to use the 6-jaw chuck for this. I actually want to use a collet chuck for this, and I'll be grabbing this with, let's see here, that one, yeah, that one. All right, a 7/8 collet here is perfect. It's a 5C collet. So here's where we get to see these stands I built in COVID and how they work for me. This is the collet chuck in question. I'm gonna put that over here. I'm gonna move my 3-jaw down there so that I don't have to move this 6-jaw very far. I'm gonna undo the 6-jaw here. It's heavy, it's like 70 pounds. I'm gonna do this one. I think you'll hear it shift in its... In a lot of shops, they have an overhead crane just for this type of maneuver. But I've built these stands that I have to do a minimum of moving around. Now, each time you pull a vise off of your lathe, each time you pull a chuck off of your lathe, you want to make sure that the mating surfaces are totally clean. I usually, and this one goes in. Let's see here. Just like that. So then I lock 3 of those. I lock all 3 of these. There's one. I do a loose tighten first. A loose tighten. A gentle. Oh, come on. That's it. I get them all semi-tight before fully tightening them. That's what I was going to say. I do a loose tight? That doesn't make any sense at all. Okay. Great. So, there is the collet chuck. And the advantage, the reason of using a collet over the 6-jaw is that even though the 6-jaw has 6 points that it's grabbing and it's nice and positive, it has the potential to mark the work. And the collet just won't. Don't get me wrong, I think you can damage the work with a collet if it was like your commitment, but for the most part, it's a great way to grab onto the work without harming it. So I'm just gonna square up the end here. That's what I'll do on both of them before figuring out the exact length I need them to be. Awesome. I was shortening these, and the reason why will be obvious in a minute. So my main two pipes that would be my new vise handles are cut to length. They're exactly the length of the old handles. They fit my rods exactly as they should. Great. Good. That is a handle. So now what I need to do is I need to mill a flat and drill and tap a hole for receiving this. And then once I do that on both of these, I will then mill a slot. But before I mill that slot, I have to choose my set screw and I have to mill a set screw to, it's a multi-step process. I got to take apart part of this vise to pull out this center handle pivot, pivot, and figure out what size set screw to put in there. So that's the next step. There's a bit of dismantling to happen now. Right. Boy. Next thing I want to do is drill and tap the ends of these to receive a 1/4-20 screw. One of the things that's great about the 5C collets is they open up quite wide, so I don't have to change out the chuck to fit these to drill them out. So now I'm going to drill it out with the proper drill for a 1/4-20 tap, and that is... That's right, it's a number 7. It is not a ton of meat, but it should be enough. Let's get a tap in there. I don't like to run the lathe for these operations for the most part. The taps are hardened steel. Get them wrong, they shatter. Go searching for parts of your eyes. All right. Lovely. So pretty. Yeah, all right. Next. So here's where we're at. I've got a 1/4-20 set screw, and I want to turn down its end to be a post. Now I want to cut past the threading, and a number 7 drill bit is effectively 200 thou. That's just a little bit north of a 3/16, which is 0.1875. So I'm going to turn this down to 0.187. Or even 0.186, and then the slot in my long piece will be 0.1875. That'll give me a little bit of slop, and it'll allow this to properly register. It'll all become clear once I do it, but basically I have to mill down exactly 200 thou out and kind of exactly 200 thou in. Zero there and take out. Excellent. So I have completed all the operations on one of these two. I've put in a slot. It's nice. It fits the set screw that I machined. It's got the seat for the handle, and that seat is far enough away from the slot that the vise handle won't be the resting spot. The unknown here is how much abuse the end of this set screw can take, and it may be that I have to like get a hardened set screw and grind it down or something like that, but hopefully it'll work the way I want it to. I have modified both of the handle pipes, handle pipes, handles Messiah. Anyway, let's do a test fit, shall we? So this is the spinny part. I don't mean to get overly technical on you. And this is the turny part. Spinny part and the turny part work together. So here I am. I'm gonna put this set screw into this hole, and you see how it's going to ride down in this channel here, right? So I'm just doing a test fit here just to make sure that the whole operation works. Oh yeah. That's nice. Doesn't go past there. Doesn't go past there. Right, there are these guys going here. Oh, wait. Oh yeah, no, that's gonna have to be that way. Right, yep. Okay, so, hold on. Gotta put in the O-ring. And I don't need the O-ring on the other side. Right, I don't. Because it won't do anything. Oh, perfect! Great, that takes some of the stress off the set screw. Now, put this guy in here. All right. I think I'm gonna take this down just a little bit. However, here is how the operation works. Pull out the handle and turn it like this. Oh yeah. Then when you're done, that can fold up and that folds back down. Okay. I'm curious how this is going to slot into my work process. I'm not positive, but I definitely want to take that down on a little bit of a chamfer. And overall right now, it's a very positive grab. It doesn't feel like there's any real resistance. The tolerances are all good. Yeah. Excellent. All right. Yeah. So the next thing I'm going to do is I'm going to clean up these, chamfer those. Yeah. And then I guess we're close to doing a final assembly. It's not the brakes per se, it's the brake assembly. All right. Let us clean. Oh, no. Oh, okay. There we go. All right, so, yep, there's the 4. I already have a spare parts bin for this workbench, which is great because, well, I'm hard on my equipment. And the 2 extra set screws that I made for this operation will remain in there. Okay, to the lathe. Well, the parts are done. I am really happy with how these came out. They look great. They look professional. These also came out looking quite nice and even, dare I say it, regular. I might just end up being a moderately reasonable machinist. So now it's time for the holy reassembly. We don't need to cover that in great detail. Because when you have a tool, you should take it apart. Every tool you have, take it apart, put it back together. Take it apart, put it back together. Like, you should know what's inside. You should know where the brushes are. You should know how the wire routes in your drill. It's really helpful. I started by taking apart my toys when I got them as a kid, and I've never stopped. Tools are toys. Yeah, I know. It's not necessarily play, but you know what I mean. All right, so it's going to be reassembly, and I'm reassembling the vices all before I put these guys back in. But I'm excited. I'm excited. I can't even tell you. First of all, I ordered a pair of these on Amazon, and like 5 months later, they hadn't arrived, and it was like, you can get a refund if you want. And I'm like, sure, but I'd rather have the object. And then I found a website and ordered them. But like, I've been wanting to do this since last fall. Mm-hmm. Not exactly since I got the thing, because I know I got this last fall. More like, let's say December. Last winter. Okay, here we go. Time for the assembly. I can't even tell you how good it smells in here. The machine oil, it's just blood in the water for me. It gets me excited. Just love that smell. Here is my beautiful Andrew Klein vise, and just like old days, I can spin it at both the fast speed and the low speed, and the action's pretty good. I like it, and because I don't like doing this, now I have this, right? Oh, look at that! Look at how fast that is! This goes to show you how impatient I am. I think this is one of the things that'll demonstrate pathologically just how impatient I am, that like, I don't have all second. There we go. And then when you want it to go away, it just goes away. And now it's not gonna ding my leg or, yeah. I'm very, very, very happy. And it looks good too. Andrew, you want to incorporate this? I'll share my measurements with you. Totally up to you. There you go. There's a one-day build. My vices are just a little bit more useful now. Yeah, I'm very happy. Thank you guys for joining me for this one-day build, and I will see you next time. Oh, I didn't even know that was there.